I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. In the previous video I laminated this huge timber here, which is going to form one of two stringers that run through the middle of Temptress, and in this video I'm going to be showing you how I shape this timber, pre-shape it before it goes in the boat, using all the information that is actually engraved on this jig within the CNC cutting stage. We'll transpose that onto the stringer, and then we'll cut the notches, we'll cut the primary bevel all the way through the bottom, and we'll get it into the near enough finished state that you see it is here. So let's get cracking with that. So we're starting out with the lamination that we built in the previous video, and the first thing that we've got to do is to put this back onto the jig and then rescribe the primary curvature of this. This is going to allow me to just take out that small section of springback that we had up forward and get the stringer down to the final dimension, because it's slightly oversized at the moment just due to the count of laminates that I used to get me enough material there. So the first thing I'm doing is marking the forward and aft trim lines, and then I'm marking the finished thickness that I need to be. So that's 164 millimeters at the rear end where the transom is, and then 127 millimeters across the lamination stack up forward here. So I start by marking that, and then I'm going to offset the lamination from the jig by a fixed amount. In this particular instance I went for 20 millimeters, so what you can see me doing here is just measuring 20 millimeters from that face of the curvature to the final trim lines that I've marked for the thickness of the stringer at either end. Then once I've got those marked, I need a handy little jig to be able to transpose that curvature from the jig onto the face of my lamination. And very shortly I'll explain exactly how I use this little jig. It's just something that I came up with on the fly, but it works really well, so I'm really pleased with that. So once I've got that primary curvature marked, I can stand the stringer back up on its edge and then start to shape that out curvature. That begins with an electric hand plane just to get the bulk of the material roughed out quickly, and then I'll dial that in a little bit closer with a hand plane further down the line. So we've probably only got around about 3 millimeters, maybe 4 in most of the places along the stringer, so we've not got a huge amount of material to remove here. And I'm just doing a check with a square to make sure that that's kept nice and true all the way along the stringer. This is pretty square to begin with because I squared up the jig that I've laminated this into, so it's actually pretty good to begin with. But as I start to plane things down, if I'm a little bit heavy-handed on one side, which it seemed that I was in quite a lot of instances, then you can lose that reference. So I'm just going to keep a square to hand at all times and just make sure that things are nice and true, because when it comes to transposing lines back across this stringer, having this bottom face square is really helpful. And you can see the sort of marking indication lines that I use there just to tell me where I've got to take material off between, and a little warning sign which is the squiggle on the right hand side there, just to make sure that I don't catch that with a planer. We'll double check that again with the square afterwards, and when I'm happy that that is nice and true all the way down the length of the stringer, we can go over to a hand plane and just shave this down, take the final little bits off as and where they're needed to get me down to the line. Okay, so the stringer is trimmed in to match the jig now, so we've got that primary curve there, and that is the curve of the outside of the hull, or the inside of the hull actually, because this is going to sit up against the inner planking. Now you can see I haven't gone too crazy on this. I've actually left the pencil line there because I want to leave a little bit of material on the stringer, just give myself some trim room, and I'll take this down to final size once it's actually on the boat. And yeah, I don't want to end up undersized and then have to put more material on. So we're going to leave a little bit to play with, but that is now the primary curve sized and the stringer back on the jig. We're up to the correct heights at the aft end, so we want 164mm here back at the outer transom point, and 127mm thickness up forward where this is smaller. Okay, now this is more than just a lamination jig. There's actually all the information that you need on this jig to completely build and shape this stringer before it goes into the boat. Certainly to get us really close anyway, which is going to save me a stack of time, and it's going to save me putting this stringer in and out of the boat a couple of times whilst we trim it and mark it. So next up, we're going to shape the rest of the string. We're going to put the bevel on it, and we're going to cut all the notches and all the bevels for each of the frames as well. Now I used this little scribing jig initially. So this was a 20mm gap from the pins to the tip of the pencil, and that ran along the inside edge of that jig. And the two pins just helped me to keep that perpendicular to the curvature of the jig all the way along. So that allowed me to scribe this curve and then get that back to where it needs to be. Got a slightly different jig now, and there are a number of different ways that I thought about doing this. Thought about kind of transposing these lines on, pinning a batten to the stringer and then using that to mark my curve. But actually, because these markings on the stringer are cut with a V carving bit, it means they're a little V-shaped channel. So
through actually no design of my own. I just kind of happened upon this by accident. If you make a jig like this with some nails in it, they're going to sit in that little groove that's cut there for the marking, and this little scribe can just run along that, and we can again keep perfectly perpendicular to that, and we can space the pencil off of it. So this primary line here is the bevel line of the stringer, and that needs to be projected 50mm in this direction in order to give me the correct bevel line on my stringer. And that's the same all the way along. So what we've got here is a set of pins. I've slightly doled off the ends just so that they're not quite so sharp. So they're just going to run in that V groove without doing too much damage to it or getting caught. And then the pencil is just 50mm away from those pins. So this should allow me to just run that in the groove, project it across to the stringer, and mark the line. Should be as easy as that. Let's give it a go. It works. That's pretty good. Pleased with that. Okay, so that worked very nicely. So you can see that we have this line here. So this is the lower side of our bevel, and obviously this face here is the high side of our bevel. So we just got to join those two faces together, and that'll get the shape of our stringer. That runs all the way along, and then you can see that distance between the two increases as we go forward because the bevel angle will get steeper. Okay, so the next thing to do is to mark the frames. So these lines here indicate the forward and aft faces of each frame station. And then these two lines in the middle here that form the little H shape are the same as this bevel projection for the primary bevel. So these are a plus 100mm offset instead of plus 50. So they're going to come 100mm in this direction. And that's going to give me the high side and the low side of the bevel for each frame. So we'll mark one of these distances on one side and one on the other. Now, because I'm doing all this from one side, I'm actually going to transpose both of those onto the frame and then just take one of them around to the other side. You can actually do it from both sides. This is a double-sided jig, so it is engraved on the underside. But just because I've got this screwed down and I'm yet to laminate the second stringer, I've got the stock just there, I don't really want to unscrew all this and flip it over, so I'm going to do this in that method. So we'll get all of those marked in for the frames, and then we can start shaping this thing.
So when it comes to marking out frame notches, you can see that I use a straight edge to project the forward and aft faces of that frame through onto the stringer. So we just carry that line on through. That gives us the position of our frame. Then I can come up to these two little cross-sectional lines that are indicating the bevel. And most of these bevels are 100mm away from these lines, but you can see this one in particular is 110 because we're up forward on the stringer where the bevels are quite deep into the timber. And you can see that the amount of that offset is marked next to each frame. So we're 110mm from both of those lines, and that gives the high side and the low side of the bevel notch for that frame at that particular point in the boat. It also transposes the angle, which you'll see is a little bit off on this frame, and that is because the stringer is starting to curve up in this forward section of the boat, but of course the frame is still vertical. So once all of the bevel notches are marked onto the first side of the stringer, I can transpose those across to the other side. So I'm just going to use a square to take those primary forward and back lines of the frame across to the other side. And then I'm going to use a bevel gauge to pick up the angle that the frame needs to be in relation to the bottom face of the stringer. So I'll pick that up on one side, I'll transpose that over to the other side, and that's just going to project these lines over. Then I'm picking up the shallower side of the bevel notch depth, and I'm projecting that over to the second side of the stringer. Just do a quick mark to ensure I know where the scrap is and where I'm cutting to, and we're good to go.
Okay, so that is all the markings done for the stringer. Now you can see that what we've got with the frame here, so we've got the notch that's going to be cut out to receive the frame. And you can see I've got the bottom bevel height there and the top bevel height there. So this is the outboard face of this stringer, and then this is the inboard face. So this one is marked to the higher side of the bevel. The frame is going to be higher here, so that's the higher side of the notch, and then because this is going to be the more angled side of it, this is going to be the lower side of the notch. So I've just transposed that line round onto the other side. This is the bevel line here, so this is the line that the bottom edge of the stringer is going to take shape to. And you'll notice that I've also just blackened off this edge along here, and that's going to be my reference for where to stop when it comes to planing. So the idea basically is that I'm going to join this corner here to this line here, and that is going to give me my correct bevel angle all the way along the stringer. And you can see that that comes a lot further down up forward, so that's going to be a much steeper angle. It's going to be something probably like that, I expect, by the time we get there. But this black line here is just going to give me an indication of when I'm coming across with the planer. So I'm going to aim to get it this kind of angle and bring the material down and then take the material across. And the second I see that line disappear, ideally I won't see it disappear, I'll leave a little slither of it there on that face because we're going to be just a little bit proud, but I'll come over and that's going to be my kind of warning sign really to not go any further.
So I'll start by roughing out the bulk of this material with an electric planer. That's just going to help me to strip that wood back a little bit quicker and get me closer to the mark. So you can see that we're still quite a way off the pencil lines right now. And then I'm going to change over to a hand plane, and you can still actually remove a hell of a lot of material very quickly with a well-dialed, well-sharpened hand plane. So leave a little bit there and it's just got a lot more control, and I can just easily sight both the lines at the same time, both the blackened edge on the inner face of the bevel and also my bevel line that I've marked on the side face. So I'm just kind of sighting down the two of those, finding a balance between the two of them as I slowly take the material down and try and get a nice even line between the two. So I'll start out with a Stanley 5.5 plane for the rear sections of the stringer where things are a little bit straighter, and then I've moved over to a 4.5 up forward just to help me to deal with that curvature a little bit better. And you can see we've got a really nice fair curve and a nice bevel to that stringer once I'm finished.
So that's the primary bevel cut in all the way along the stringer. It's looking really nice. You can see I'm just a little bit high on this, and I'm just going to leave this here so I've got a slight bit of trim room for when I get this into the boat. So and kind of the pencil width, maybe a touch more, 2 or 3 millimeters. And then you can see I've just taken this across, so I've got a uniform pencil line along this side, a couple of millimeters again. And that's a really good and clear indication. If you don't have that pencil line there, you're trying to just kind of catch the light on the timber and it's not quite so clear. So having that pencil line just helps you to bring that in slowly and actually get a really uniform line all the way down the length of that. So we're looking good. That's as much as I'm going to do on that for that bevel. I say I'm just going to take down that final little bit once this is in the boat, and I'll do the last little bits of trimming, shaping and fairing once we've got some frames sat in it. So speaking of that, let's get on to cutting the notches for the frames next.
Now, quite a lot of people have been asking after my Japanese handsaw, and the keen-eyed of you will notice that I've recently been favouring using the Western style tenon saw instead. Now, I do still use my Japanese handsaw quite a lot, and the two of them very much have their own merits. But as you will see, I've gone back to the Japanese saw for this particular operation. Now, the primary reason for that is that the two of them have got very different approaches to the way that you make cuts, and I find that the Western style tenon saw is a much more controllable saw when you're working in a more controlled environment. So that would be on a bench or when you're holding something in a vise. Where the Japanese saws really come into their own is when you're working in less than ideal conditions. So here I'm sort of on my knees working down on the floor, or if I'm working inside a boat, then the Japanese saw is definitely my preference there. And I think the primary reason for that, this is certainly what I've read somewhere anyway, somebody correct me if I'm wrong, but I believe that the Japanese tools were designed because a lot of the woodworkers actually worked on the floor, so they would be holding pieces of timber with their feet rather than working on a bench. And that's the reason that these cut on the pull stroke, is that the blade kerf can be much thinner and it can allow you to cut in kind of less than ideal scenarios like that. I certainly find that's the case for me anyway, and I really favour it in operations such as this. Plus, we're also dealing with quite a deep cut here, which of course a tenon saw wouldn't really be ideal for. So this most definitely worked out for me in this case. So I do still use both styles of saw. Sometimes I prefer one, sometimes I prefer the other, but they definitely both have their place within my workshop.
So there we go. All the notches cut in, bevel shaped. We're pretty much done on that stringer. You see that I've left these just a touch too high as well, so we've still got the pencil line there. A little bit of trim room just to get that frame set perfectly at the right height when it comes to setup. And then a touch of trim room on the bottom bevel of the stringer when it comes to shaping the bottom. So that is stringer number 1, beveled and notched. I'm really pleased with how that system's worked actually, and I'm glad that I've continued to refine things with these plans, because the more work I can do now, the less there's going to be to do when the boat goes together. And all of these parts being pre-shaped just means that things are going to slot together, fingers crossed, and everything's going to fit, and there'll be minimal trimming work to do. We should be able to get onto planking this boat quite quickly, I think, but I'm not going to get too ahead of myself. So obviously these dimensions are taken off the stringer jig, which is developed from within CAD, and so those dimensions are pulled from there. One thing I'm going to actually do is just measure that and compare that to some of the frames that I've already built, because that's going to be a really interesting comparison. In theory, this should match what we've got on the frame. So let's just give that a go and see how that works out. So I'll grab a ruler and we'll take a look at frame 3, because this is probably the easiest one to highlight this on. So this is where our stringer is going to come through, and you can see that everything that's going on here should really match what we've got in that notch in the stringer. So this is the total height of the stringer. It's going to sit down into our bulkhead, and then we've got our angled frames. So this represents the shallow side of the notch and the deep side of the notch. So I'm just going to take that measurement off there. That is 75 millimeters on the internal face. That should match what we have here, which is 75 millimeters. That's a stroke of luck. Let's try the other one, the smaller side. That is about 78. 78. That's a nice confirmation. I'm really pleased to see that. From my point of view, these are all derived from within the CAD model, but the way in which I've actually got these notches and all the markings on the frame actually comes from a very different approach to how we get the beveled parts on the frames. So when the two of those kind of come from completely different angles and then join up together with the same dimension on the actual physical parts, that's really quite pleasing, and it means that this is quite likely that it's all going to fit nice down the line. It means that we haven't got any errors induced along the way, so I'm pleased to see that. But time will tell. Setup day will be the real test for that, and this is not far away now. We're getting gradually more components together so that we can get this put together. So that is stringer number 1 shaped. I've got another stringer to do. I've got a little bit of prep work to do on the frames to get them ready for setup. So in the next video, I think it's going to be a bit of a kind of jumble of just getting everything ready to be in a position to possibly get this thing set up. That's going to be an exciting stage to get to. So that's what we'll cover in the next video. Thank you for watching this one. I hope you guys enjoyed it, and thank you as always to all the patrons that are offering additional support to help me try and fund this project. Massively appreciate it. Thank you also for watching, and I will catch you in the next one, hopefully. Stick around, guys. Cheers.